So now let's talk about adding node pattern as well as some specific symbols in our drawing. Now here we have this drawing with this specific view where we have two kind of patterns for holes. So we have the linear pattern here where these holes are added along two columns and four rows. Then we have the circular pattern. Now here we want to add labels for all of these holes. And I'll start with this rectangular pattern of holes. So I'll go to node and I'll actually add a placeholder for just one of these holes, and I'm going to add it maybe about here. So I'll click and I'll type A as the placeholder for that hole. Click outside and now you can actually move it up. But before I do that, I'll exit out of this node option and I'll move it maybe about here. And we are done. Now, instead of adding the same kind of node for all of these other holes, I'll simply go to this linear node pattern and then I'll create a pattern. So let's go to linear node pattern, and now automatically you'll see that it is selecting X and Y axis. Now, if you don't want to use X and Y axis as reference, you can click here and then select X axis and then Y axis for yourself using the drawing view. In this case, X and Y is making sense, so I'm not going to change it. And I'll now go to nodes to pattern and then I'll select this node. And done, our node is selected. Now let's select number of rows and columns. So here number of column is 2, that's along X axis, along this one, which is right. Along Y axis we need to make it 4. So I'll type 4 and tab key and done. But we have a problem. This is going up, it should go down. So I'll just click here to reverse the direction and then I'll change the gap along X. The gap value is right here. So I'll just click here and well, 50 looks about good, but maybe I'll just make it 54. Well, that's better. So with 54, this is the gap, and now we need to fix this distance. So this is also about right, but maybe we can fix it with, well, 12 unit. So 12 unit looks good. So with that, now everything is right where it should be. Just click OK, and we have the node pattern. Now we can definitely modify this pattern very easily simply by double clicking here. So instead of just adding, simply now type B and double click, type C and so on. So you can just now add all these placeholders. And we are done. Now in a similar way, if you want to add placeholder for these holes, well, the workflow is same. So I'll go to node and I'll just add the first node maybe about here and I'll name it 1. All right, here we are. Now I'll press escape key and I'll move it maybe inside this slot. Now I'm doing it on purpose because if I add it here, all the other patterns will just overlap these lines that I don't want. Now I'll go to circular node pattern. And here you need to start with a circular edge. Of course, it is not selecting any circular edge now, but first let's go to node to pattern and then select the node. Now it looks like it just automatically selected a random point here as point 1, but we don't want it. As you know, I'll select this point and I'll move it right here at this center. All right, now in number of items, let's add 7 because we have 7 holes, and there we are. We've got placeholder for all of these holes. Once you are done with all these changes, click OK. And now you can once again modify all these nodes. So this is one of the way you can use this node pattern to add several rows or columns or maybe circular pattern of nodes. Now let's talk about adding some specific symbols, and here I'll start with the geometric tolerance symbol. Now the geometric tolerance symbol is, well, the tolerance symbol which you can associate with your dimension. For example, here I'll go to smart dimension and I'll add dimension for maybe this hole right about here, and I'll actually change the direction of this dimension. So I'll just make it horizontal. So I'll go to leader and custom text position. I'll activate it and I'll make it horizontal. All right, click OK. Now with this one, I want to add the tolerance value as well using GDNT or geometric, well, symbol, tolerance symbol here. So I'll simply go to this geometric tolerance. And here we can add a feature control frame. Now this is something which is not directly associated with SolidWorks, and it's a completely different topic in itself. So if you want to learn more about GDNT, you need to refer the ASME handbook for the same. Now, if you know a little bit about GDNT, you'll probably understand what this feature control frame is and how it can be used. But in this case, I'll simply add one, the generic one, which can be added with this kind of feature or this kind of dimension. So here I'll simply select this point to add the feature control frame, which should be associated with this dimension. And now you can start with one of the tolerance symbols. Now this is the position tolerance, so I'll select position option right here, and then here you can start with the actual tolerance value. So it is 0.01. Let's maybe assume that the tolerance value is 0.02, so I'll add it here. Now you need to specify the tolerance zone, so it is circular, so well, select that value, diameter value, or the diameter symbol that should be associated with this. Also, if you want to add the material condition modifier, that's right here. So go to material condition, and then you can add the maximum material condition, least material condition, or regardless of feature size. I'll select maybe maximum material condition. And now I'll click on add datum. So here you can add the datum plane. So it's A, I'll keep that. Then I'll select add new, and then I'll add B as the second datum. Now these two things are simply the datum planes which you can later add in your drawing. So we are done with this, and then click done, and we have our feature control frame added. Now if you want to modify this feature control frame, you have these plus symbols that you can click to modify it further, but I don't want to, so I'll click outside. Now since we have already added this feature control frame with datum A and B, these two should be specified clearly in the drawing, which we haven't. That you can do using this datum feature. So datum feature is the reference feature or the reference plane or the feature of your part which will be used for measuring this dimension. Now in this case, I will specify the first datum feature as this one. That's datum A right about here, and then datum B is right about here. Now we have specified both the datums. We can simply see that here in the feature control frame as well. So A and B, they are properly defined. Now datum target is another thing which is used for situations where the datum feature is not uniform or it has deformities. In that case, you can specify any specific point or any specific range for calculation purposes, and that's the datum target. Now when you click datum target, it will let you add the datum target of three types. You can add the point target, you can add the circular one, or you can add the rectangular one. Also, you can select the type of datum target, text, or the symbol that you can add. In this case, I'll select the default one, and maybe I'll select the circular area. Now all you need to do is specify the datum target area. So maybe I'll just, for the sake of simplicity, select a point right about here, and then I'll add the datum identifier here as well. So for now, I'll simply click on these 2 points and now click OK, or you can press escape key. Now I'll select this and I'll make the modifications. Well, the first one here is the datum identifier. So it should be, let's say A1 is what we are selecting for this, and then you can select a diameter value, for example 2. Now when you select the diameter value, it will automatically change the size of that hashed area as well. So based on whatever the diameter value you're entering, so maybe 3 is just going to make it a bit larger, and with that click OK, and here we are. We have got this datum target. This is the area that should be used for measurement, and automatically it will add the value. Now in a similar way, you can add some other features as well. For example, surface finish symbol, if you want to add it, that's right here. Select it. Now here you can fill all of these other parameters. Well, the very first thing here is the type of symbol. So here this is the basic surface texture symbol. Then we have the second one where machining is required, and here machining is prohibited, and some other symbols. So you can use all of these based on the type of surface finish that you want to add here. Also in the symbol layout, you can add different values. For example, the production method, average roughness, waviness height, minimum material required, and also direction of lay using all of these options. For example, if you want to change the direction of lay, that's here. If it is radial, select that. If it is parallel, select it, and it will automatically add the symbol which is related to that direction of lay. In this case, maybe let's select perpendicular as the direction of lay. And now if you want to add the values, well, you can add it right about here. So I'm not going to add any other value, and with that I'll simply click OK, and now it is added right here. But in this case, we definitely don't want to add it here. We need to associate it with a surface. So in this case, I'll just associate it with this one, or you can just delete this and add a new one. And I'll now associate it right here, and I'll click OK to add it. Now if you want to add the weld symbol, definitely that's here. And here also, if you know how to add these symbols, well, you have the option for adding it here. So for example, on the welded side, if you want to add the symbol, that will go here. On the opposite side of arrow, that's right here, and so on. So once you are done, click OK, and then select the corner where you want to add this weld symbol. Finally, we have the hole callout. Now hole callout can be added for holes, and here once you add it, it will automatically add its complete value. For example, here we have several holes. I'll simply select this hole right about here, and then I'll just click here, and we have the hole added. Now in this callout, we have several information. For example, number of hole is right here, and this is diameter of hole, and this hole is through, which is it's completely going through the entire weld face here. Then we have the countersink here. This is the countersink symbol, and that's the diameter of the countersink part and the angle of that countersink part. So all these information are added automatically here using this hole callout, and you don't have to add it manually. Once done, you can press escape key. So in this way, you can add node pattern and these different symbols in your drawing.